This is classic YouTube, right? It's all about the thumbnails. Oh man. This web. This is my little light for my board, by the way, in case you're wondering. Actually makes a decent camera light. Look at that. So this versus this. Like that. That's too bright. Oh, that's worse. There you go. It's actually pretty good. All right. Anyway, enough playing around with the light. So I just got my new programming book. Shout out to Nick. Nick, I need to talk to you. I gotta figure out my Discord setup so I can send you a message. So it's Code Complete Second Edition by Steve McConnell. This book is a lot bigger than I thought. Do you see how thick this is? Do you see how thick this is? Just to give you some perspective. So that's a little bit more than 3 fingers. That's pretty thick. It's like 800 and something pages. So I'm not the fastest reader. So this will be an interesting journey. A little bit more than what I was anticipating, but I did a lot of research in terms of like what's good. What I wanted was I wanted a so as you know, I mean, we're all on this journey trying to be programmers or better programmers for those of us that already are programmers. And I know for me personally, I don't want to just know the techniques. I don't want to just know in terms of I know Python, I can write something in Python. I know what a list is. I know what a tuple is. I know what a class is. I know what a function is. I know what a generator is. Right? I don't want to just be sort of, I don't know if this is really a term or not, but a technical programmer. And maybe we need to get into programmer versus developer versus software engineer, right? And I think what I'm leaning towards software engineering would be my guess in terms of the best word to use. But I don't wanna just understand how to code in terms of to make it happen, build a list, extract the list, manipulate the list. I want to be able to do it well, right? So for example, I guess there's 2 different things to think about, right? There's the efficiency and sort of intelligence of your design in terms of, you know, is using a list, is that the best way to go? Is that the best approach for the problem you're trying to solve? Should you be using a dictionary? Should you be using another construct that would be more efficient, more relevant, basically make more sense based on what you're trying to solve? So there's that. And I guess that's getting into the design process. But then there is another part which there's some overlap. It's technically part of the design process in some ways, but there is I guess the methodology. So I guess a fundamental concept is you have the SDLC, right? Software Development Lifecycle. Planning, research, testing, deployment, So that's one of the things that is important to understand. But in general, there's a lot of other things. Like, for example, you know what? And I guess that's what a good way to say what I'm targeting is I'm targeting being more proficient with the SDLC. That's what it is. Right? Because the SDLC sort of defines the entire methodology in terms of how software is created from concept to delivery, or rather to maintenance, because I think maintenance is the final phase, right? Because after you've delivered the product, you still have to maintain it. So that is the heart of creating software, creating and delivering software, right? Or the software business. So what I would then be seeking beyond the robotic, you know, do A, then do B, then do C, the fundamentals, is the nuance in terms of the approach. Like, what are the questions that you need to be asking during your design phase or your planning phase? So, planning phase, we understand what planning is in general, but what should that look like? Like, we need to do that for our trading platform, right? That's coming up next. So, it's definitely apropos that we are, well, that I'm stepping up this knowledge. It's great to know Python, but there's more to it than that, right? So, what should your planning phase look like? What are the questions to be asked and answered during your planning phase, right? And then we go through the full life cycle. So let's run through that right now. So one moment, one moment in time. Nick, I keep telling you, man, I'm not a singer, um, but I do sing often in my videos. I'm not a professional. I know my voice sounds heavenly, and it's kind of shocking that I'm not like making a ton of money from selling albums, but I'm not a singer. Anyway, so we have this is not, I guess. So this again, people use different wording. So it says requirement analysis, design, implementation, testing, evolution. Right? So that's the fundamentals. So we could just sit down and say, okay, fine. So I'm going to work on my requirements and my analysis in terms of what we're trying to accomplish with the software. And then I'm going to move and I'm going to do my design. We're actually going to solidify things. So we know generally we thought in sort of the research phase or the idea phase, we thought about, okay, we need to have a client connected to the server, and then we need to be able to send these messages, we need to do validation, right? Then design, we could solidify and say, okay, so we're going to use a dictionary, Python dictionary, that's our data structure. And then as far as the networking component, what we're going to do is we're going to use these third-party libraries that are designed for advanced network handling or whatever. So we're not going to need to do a lot of work in the networking side of things because these libraries will handle a lot of the stuff for us. We'll just need to make some minor tweaks and be able to figure out how to manipulate this existing code base, right? So that's the details, right? What platform, right? Is this going to be a web-based thing? Is it going to be running on Windows? What environment is all that stuff? Design, implementation. So I would take that as the actual coding, right? So you've built the code, right? So here's the code. It actually does what what we're required to do, or it does the functions that were defined in the requirements, right? Then we have testing. So now we're going to test and make sure that so on a surface level during implementation, we can start up the software and like do the basic, start the client, start the server, send create an order. Everything seems to be fine. But what happens if you click on send really quickly? Rapid succession. Send. What happens if you enter a large number? What happens if the system's low on resources? How does it behave when it's low on resources? How fast can this thing run? Before it starts bogging down. Can all of the functions that that are requirements, do they all work? Right? the developers may have tested things in their environments, but now in the final release where you're now in a different environment and you now have all the code working together, that could introduce things that didn't come up in the developers testing, right? And then you have the evolution, which I would presume that's more like software releases. So, you have enhancements, bug fixes, things like that. Um, so that's the fundamentals, right? So we could take what I just said, all the information I just gave you, is enough for you to run with it and use that to effectively build software. But in order to do it well, in order to be most proficient at it, in order to excel at it, you would need to implement all those basic requirements of the SDLC process um, in an intelligent, efficient, and effective manner, right? Because I could sit here and think about, a reasonable, intelligent person could sit here and think about like design phase. Okay, well, how are we going to do design? Well, let's think about what we wanted to do. Let's look at some similar products. You know what I mean? Like you could sort of theorize and maybe you reinvent the wheel while you're at it a little bit. Or you could perhaps, you know, take advantage of the knowledge of many people before you that have been doing this for decades. Take advantage of the resultant accumulated knowledge of all of the developers and programmers and businesses and universities and all of that accumulation of knowledge. Take advantage of that to not reinvent the wheel and to follow. So how do you execute on your SDLC? Right? There's one thing to like, okay, yeah, I know what design, whatever, but the nuance of how you do it. And again, you can reinvent the wheel and you can think logically and you can come up with a good strategy. And maybe you're genius or something, or you just have a real knack for software design, and on your own, you can come up with something that is as effective as what you could get from any book or school, or maybe even better. Right? You're amazing. You just have a real knack for this thing. Um, However, that's not likely going to be the case. And also, you got to think about efficiency. Most of the focus should be spent on creating a great product, in my opinion. I think the focus should mainly be on creating a great product. And then to do so, you have to define what a great product is, right? You have to think in terms of from a profitability standpoint, from a scale standpoint. I mean, there's so many different perspectives that you need to consider. And that's where the attention should be spent. Spent on doing the things that are going to lead to the product being successful and profitable, as opposed to focused on like how should we do the design process. You know what I mean? These are things that, one second. Anyway, so these are things that you shouldn't be wasting time on, right? Rather than try to figure out on your own like what's the best way to do these things, I think it's advisable to follow industry standards, best practices. I mean, if you see an area to innovate in particular, fine. But first, start with what works, right? So start with what is tried and proven to work. What we know to be effective, right? And then if you want to take that and say, hey, why do we do it this way, right? And you want to do adequate research so you can understand why we do a certain thing a certain way, and then really understand whether that actually is the best way or it's not the best way. Because maybe you think it's not the best way because you don't really fully understand the process and you don't understand why that decision was made to do things in a certain way. All right, so that's fine. If you want to pick on something in particular and enhance it, go right ahead. I'm always for innovation, but again, the majority of the focus should be on developing the product. Right? Focus on the product, your features, user experience, um, the performance of it, and whatever considerations are most important for your product. Security, you know, security, you know, scalability, whatever it is, right? Cost. Um, so yeah, so that's why I got this, because I want to figure out, what's, rather than stumbling around in the dark in terms of, okay, I can sit here and master Python. I've been studying a lot of Python. I've been growing so quickly, but knowing how to code in Python is one thing, like knowing the language, versus knowing how to engineer software. Like, what is the best, most effective way to engineer software to where you get the best results, right? So that's what I'm looking for. Software design strategies. So this is a practical handbook of software construction. Microsoft. I didn't realize this was Microsoft Press. I didn't realize it was Microsoft Press. $54. So it says, discover the timeless techniques and strategies that help you design for minimum complexity and maximum creativity. Reap the benefits of collaborative development. Apply defensive programming techniques to reduce and flush out errors. Exploit opportunities to refactor or evolve code and do it safely. Use construction practices that are right weight for your project. Debug problems quickly and effectively. I've been doing some debug this weekend for sure. Resolve critical construction issues early and correctly. Build quality into the beginning, middle, and end of your project. It's good stuff. Whether you are a new or experienced developer, Code Complete Second Edition teaches you the best way to think about programming. And that's what I want. The definitive guide to software construction, the one book a programmer packing for a what? Oh, I'm sorry. The one book a programmer packing for a desert island should take. The one book a programmer packing for a deserted island should take. Interesting. C. McConnell is one of those rare souls. I can't spell souls to save my life, so it's good for me to see. So it's S-O-U-L. S-O-U-L. Anyway, those rare souls who practice the state of the art and demystify it too. Steve McDonald knows more about building software than anyone else. We're lucky he has packed all his insight and practical experience into this important and original book. So, interesting note, I cannot read fiction. I will fall asleep after 5 pages. I don't care what it's about. It could be my favorite genre in terms of movies, anything else, but I don't care. I read to learn, right? That's the only reason I read. Otherwise, not interested. So I could read a boring book. Look, let me tell you the kind of nerd I am. I'm the guy in 6th grade that would go to the back of the, what was it, encyclopedias back then? Back of the encyclopedia to see the crazy advanced stuff that we were never going to ever get to in our classes. I remember I was looking at some kind of chemistry stuff. I was looking at chemistry stuff in the 6th grade. Wow. No life whatsoever. Anyway, not much has changed. Spent my whole weekend learning Python. Yeah. Part 1, laying the foundation. Welcome to software construction, metaphors for richer understanding of software development. Measure twice, cut once. Upstream prerequisites. Key construction decisions. Design and construction, working classes. High quality routines, defensive programming. The pseudocode programming process. General issues in using variables. the power of variable names, fundamental data types, see, variable names, something like that. Like you know Python, you know how to use variables, when to use them, but little issues like your naming convention. Like how are you naming your variables? You know, so I'm interested in that. Fundamental data types, unusual data types, organizing straight line code, using conditionals, controlling loops, unusual control structures, table driven methods. So these is like create high quality code, variables, statements. That's the broad view of what these sections are dealing with. Code improvements, system considerations, software craftsmanship. Um, did they got an infinite loop going on here with the menu? Because it says laying the foundation. Didn't we do that already? Yeah. Part one, part two. Oh, okay. This is it's like the same menu but in a different format. Welcome to software construction. Welcome to software construction. What is software construction? Why is software construction important? It's kind of weird. And it is a variable section, which is really long. I mean, it's 800 pages, right? Creating high quality code, statements, code improvements. I'm curious to know what they have to say about loops. I wonder if they go into algorithms. So, let me. So key construction decisions, programming language, programming convention, your location on the technology wave, selection of major construction practices, design challenges, key design concepts, designing building blocks. So I'm not going to be able to read all of this before we start our process, so I may be revisiting this as we go along. I'm going to try to do as much of a skim through this to get a fundamental understanding of how we should proceed, and then we modify as we go along. High quality routines. There definitely will be mistakes made, for sure. Defensive programming, high quality routines, pseudocode. So let's take a quick look at variable names. So 259, let's see what it says. And I guess in theory, I don't have to read the whole thing. I can look at what's in here and selectively choose what I want to jump right into. Like, for example, variable names, right? I don't know why there's these words in programming that I feel like I don't pronounce. Like I want to say debug, and then verb. What's the other one? Like, why is it all programming words that I there's another one I forgot. I don't know. It's weird. It's annoying. Oh, parenthesis. I used to want to say parentheses, but it's parenthesis. All right. Bonjour. I'm speaking other languages and I can barely speak English. Anyway, the irony is not lost on me. So, consideration and good names. You can't give a variable a name the way you give a dog a name because it's cute or it has a good sound. Unlike the dog and its name, which are different entities, a variable and a variable's name are essentially the same thing. Consequently, the goodness or badness of a variable is largely determined by its name. Choose variable names with care. Goes without saying. Let's see, there's deeper knowledge here. Java example of poor variable names. So triple X equals Fido. X equals X minus XX. What's happening in this piece of code? What do X1, XX, and XXX mean? What does Fido mean? yeah, I try to make the variable names have meaning in terms of what I'm trying to do. I do try to spend some time. Sometimes I think too much time, but I'm very, if I'm gonna pick this variable name, I wanna pick a good one, right? I'm gonna be using this. I have to debug with this thing. Um, I want it to make sense. I want it to be something where in the future, when I'm trying to figure things out, I will look at it and quickly understand what that variable is about. Of course, comments are good as well, but also good variable names. The most important naming consideration. The most important consideration in naming a variable is that the name fully and accurately the entity describe the entity the variable represents. An effective technique for coming up with a good name is to state in words what the variable represents. Often that statement itself is the best variable name. It's easy to read because it doesn't contain cryptic abbreviations, and it's unambiguous because it's a full description of the entity. It won't be confusing with something else, or confused with something else. And it's easy to remember because the name is similar to the concept. I got a bizarre idea. Should I do a nightly reading series? I'll read some of this, and it'll be good because if I'm scheduling it, I'll have the accountability of you guys expecting it every night, and by having that accountability, I'll be doing it every night, and by doing it every night, reading, I would be learning pro one-liners. So I don't know. I don't know. I don't know. I don't think that's really been a done thing on YouTube, so maybe I'll be the guy to start that trend. Anyway, guys, Nick, I got an idea for you, man. Something that we need to work on. I'm gonna try to hit you up on Discord. All right, CPU squad. All right, be good, guys.